Hello, hi everyone, welcome back to the channel. So, continuing this binary search series, in this video lecture, we'll be learning this concept upper bound, which is also implemented using binary search. So, what is upper bound? It is very similar to the lower bound. In lower bound, we find an iterator pointing to the first element in the range first to last that is greater than or equal to the value that we pass in as an argument. While in upper bound, it returns an iterator pointing to the first element in the same range from first to last that is greater than the value or last if no such element is found. That means the element to which this iterator is pointing is greater than the value that we are passing. So it must be the value, okay, the element to which we are pointing must be greater than k. For instance, let's take an example. So let's say we want to find an upper bound to the element 30 in this array. So we want to find the very first occurrence of an element which is just greater than 30, and that occurrence is this 40. Fine, and the index for this 40 is 0, 1, 2, 3. It is 3. Fine. So how do we find that? How do we implement this function upper bound? Let's see. It is very similar to the function lower bound in which we used binary search to find the target iterator. In the same way, we'll be finding the target element in this array. So let's see how we can do that. So it's just going to be the typical binary search with a little modification as we did in the lower bound. So let's initialize two pointers L and R here. So L points to the first element, R points to the last element. Similar to the binary search, we find the middle element, and the middle element would be 0 plus 4 divided by 2, that is 2, which is this one. And I compare this middle element with the element which we are passing as an argument, and I see that this is equal to the element we are searching for. So this can't be the lower bound. So this can't be the upper bound because we want to find an element which is just greater than 30. That means I will find my element in this range, that is after this 30, after this index. So I reinitialize the L to this position. Now the search space reduces to this one. Here I again check for the middle element. The middle element would be 2 plus 4 divided by 2, that is 3, and that would be this one. So is this greater than the element which we are passing? Yes, it is. Since it is greater than 30, it can be the potential answer. So I store 40 as my answer for now. And the search space is reduced to this one, that is from L to this R. Why? Because I want the very first occurrence of the element which is just greater than 30, and there can be another element which lies in this range before R, before this middle element, which is greater than 30. That's why I am searching for the possibility in this range. I again calculate the middle element for this range, that would be 2 plus 3 by 2, that would be 2, which is this one, and I see that this is less than the, and I again jump back to this element and I see 30 is not the candidate which we are searching for. So I reinitialize the L to this pointer, that is 40. So L and R are staying at the same position now. So L and R at the same position. So this range contains only one element. So there is no way the upper bound can be anything else than this element. And this element is 40 indeed, which we already had, which we already has in our answer variable. So I return my 40. So I return the answer. That's my answer. So in this fashion, I find the upper bound, and it is very similar to lower bound. If you haven't watched that video, go and watch that video, because these two concepts, that is upper bound and lower bound, are very crucial for this topic of binary search. So let's jump to the implementation part. Okay, so this is the implementation of the upper bound function. So this is the implementation of the upper bound function, which you pass in the value, the nums array, and here's my starting index, which is 0. So we are standing, so we're putting our pointer, the first pointer, on the very first element of the array, and this is the second pointer on the last element. This is for the middle element. This is the answer, which is by default the index which lies after the last element, because in case we don't have an upper bound, we return n. Then the usual binary search, find the middle element, check if the middle element is greater than the value which we are passing, then this can be the potential answer. So store this into the answer variable and reduce the search space to the first half. Fine. Otherwise, reduce the search space to the second half, because the upper bound lies in the second half range. So in this fashion, I will find the first occurrence of the element which is just greater than this value which we are passing, and I return that answer right from here. So we are returning answer, not this start. So we return answer right at the end of this function. So in this fashion, this function is working. Let's jump to the implementation. Let's jump to the time and space complexity. So since this is just the binary search, the time complexity would be log of n, while the space complexity would be constant. Let's jump to the implementation part. So this is my upper bound function. So this was the lower bound function, this is the upper bound function. So calculate the let's calculate the size of the array, the left pointer, right pointer, and the answer variable. Okay, and let's run the binary search algorithm. And whenever I find the middle, all I have to do, the only change which I have to make in this function would be just remove this equal to sign, and then I would have my upper bound. Rest the code is same as it is for the lower bound. So and I will return the answer right at the end of this function. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and subscribe to my YouTube channel for the regular updates. And I hope you got the implementation, and I hope you got the implementation details of the lower bound and upper bound function in this video. So stay tuned with me in this series. So stay with me in the series. We're going to solve a lot of problems of binary search, and that will help you to identify these problems whenever they appear in a contest or an interview. So I hope to see you in my next video.